Hey guys, in this video I'm going to walk you through how to solve the 5 hardest maths questions in the 2023 Year 6 SATs. Okay, let's get started. Paper 2, question 26. This formula is used to estimate the mass in kilograms of young children. Mass equals 2 times, and in brackets, age in years plus 5. So we have a formula here. This is an algebraic formula that we are expected to use to apply to find our answer. So I'm just going to highlight this is our formula. The mass of Megan's brother is 16 kilograms. Use the formula to estimate his age. Okay, this is in bold. Age is in bold, so it's making sure that we know which part of the formula we are looking for. Is this part. Second part is Stefan's sister is 4 years of age. Use the formula to estimate her mass. So we're going to stick with the first part of the question first. What this question is asking you to do is to use the formula, and what we're looking for is how well you understand the different parts of the formula. Okay, so let's look at the formula. The mass is the same, which the mass at the top it says in kilograms. So the answer in kilograms is the same as the age in years add 5 doubled, okay, because it's 2 times and then in brackets the age in years plus 5. So what we're going to do is we're going to start to plot in the information that we know. So we know the mass of Megan's brother is 16 kilograms. So we can say that 16 is the same as 2 lots of the age plus 5. Okay, so we can start to break this down now. If 16 is, so we don't know what the age is in ages, so we can't add 5 yet, but we can work a bit backwards. So 16 is the same as 2 times something. We know that 16 is 2 times 8, don't we? So if I was to put in a different colour on top, we know that that bracket has got to equal 8 because 16 is the same as 2 times 8, right? So if we know that the age, so if I wrote that out again, the age, the mystery age plus 5, mystery age plus 5 is the same as 8. Well, that helps us a lot, doesn't it? What plus 5 makes 8? Well, the answer is 3. Okay, so now we can just put all that back into the formula to double check. The mass is 2 times the age in years plus 5. So if Megan's brother is 3, we would say 3 plus 5 is 8. Times that by 2, it's 16. And yes, that works. Okay, so we just subbing into the formula the bits we know and then kind of working backwards and forwards until we find that missing value. Okay, so the next bit is we know what Stefan's, how old Stefan's sister is. We've got the age here, okay, and we need to find out what the mass is. So for this one, we would say the mass is equal to 2 times, and then we know what her age is here. It's 4, so instead of writing age, we can put 4 plus, so put 2 times 4 plus 5, okay, because we know the formula says plus 5. Now we can do the bit in brackets. 4 plus 5 is 9. So that means we're doing the mass is the same as 2 times 9. We know what 2 times 9 is. 2 times 9 is 18. So Stefan's sister is 18 kilograms. Now let's just double check that if we wrote it out. So 18 kilograms, we're saying, is the same as 2 times, and then we are saying 4 years old plus 5. So 2 times 4 plus 5, 4 plus 5 is 9, times 2 is 18, and that is correct. Paper 2, question 24. 1,200 pupils were asked this question. How important is it to have a break when using a screen? This chart shows the results. And you can see we have a pie chart. The pie chart is sectioned off into 3 parts. One part of the pie chart is too small to fit the words on, so the words are just off the pie chart, but you can see the line is indicating that that is the section it refers to. So we've got a very important, a quite important, and a not important. Now we have the percentages for not important and quite important, but we do not have the percentages for very important. So we've got 12% here, 41% here, and nothing here. And the question is asking us how many pupils answered very important. Important to note as well that it's how many pupils and not the percentage, because on our chart we've got numbers in percentage, which is not the same as how many pupils, okay? When we're thinking about how many pupils, we need to refer back to this information, 1,200. Now, the first thing to note is that a pie chart represents all of the data. Okay, so this pie chart represents 1,200 pupils. So the pie chart will also represent 100%. So the first thing we can do is we can subtract the not important and quite important from our 100% to figure out what percentage very important is. Now you could either do 100, subtract 12, subtract 41, or you could do 12 plus 41, which I'm going to do. 12 and 41 is 53. And I would then do 100%, take away 53%, which equals 47%. So I know that my very important is 47%. Okay, so all we've done is we found the missing percentage. That's still not our answer. The question is asking how many pupils. So what we now know is that we have 47% of our pupils that were questioned chose very important, and we know there were 1,200 pupils, so we are finding 47% of 1,200 pupils. Okay, so if you are not sure how to calculate percentages, or indeed how to analyze and read pie charts, then there are ebooks on pie charts. That's the statistic ebook, covers all things to do with pie charts. And you can also find stuff on percentages in my ratio ebook. So there are things to do with percentages in the fractions book, but to actually calculate percentages of numbers is in the ratio ebook. So I'm just going to go through a quick way to solve this now, and I'm going to do 40% of 1,200 plus 7% of 1,200. So I'm actually going to find 50% of 1,200 and then subtract 3% of 1,200. So I'm just going to do it in a different colour. So I know that 50% of 1,200 is 600. And I know that 1% is 12. So 3% is therefore 36. And I'm just going to do 600 subtract 36 because that is the same as 50 subtract 3 is 47%. So 600 subtract 36 will give me my 47%. And you can write this in a column subtraction, or you can just do this mentally. So 564 pupils. There are different ways of calculating percentages. That is certainly not the only way. And you might have done 40% plus 7%. You might have done 1,200 times 47 and then divide your answer by 100. There are lots of different ways to calculate percentages. But the important bit is that you have realised that you find the missing percentages by subtracting the two sections from 100%, and then you use that to find that percentage of the amount of people that were in the survey. Paper 3, question 20. The length of this rectangle is 6 centimetres. The width is W centimetres. Anytime we have a letter to replace a number, we are working with algebra. Again, we have this, not actual size. That means do not use a ruler to try and answer the question. You use the information. You use maths and information to work out the answer, not a ruler. Circle all the methods that can be used to work out the perimeter of the rectangle. Now it's got in bold all. That means that there are possibly more than one method. And it's also got perimeter in bold. That means don't confuse it with area, for example. Okay, so all and perimeter are in bold. So to work out the perimeter of a rectangle, we need to remember that the perimeter is the outside. Okay, so stuff on area and perimeter is in my measurement ebook, so be sure to check those out if this is something that you need a bit more support with. So if I want to find the perimeter, I need to add around the outside. And with a rectangle, I know that this is going to be the same as the bottom and this is going to be the same as the side. Okay, so we could do a process of elimination. So W times 6, note we're not going to have anything that involves multiplying because that would be area. W times 2 plus 12. Well, W times 2 we do have because we have a W and a W. And then plus 12, we do have plus 12 because we've got a 6 and a 6 that we need to add. So we do need to add 2 W's and then the 2 6's. So W times 2 plus 12 does work. Now it says circle all the methods. So something very important is also just to make sure when we're reading the question that we follow the instructions. So it says circle ones that can be used. So I need to circle that to show that that is correct. 2 lots of W plus 6. Is that correct? Yes, it is because, put my W back there. All it's saying is that we need 2 lots of W plus 6. I do need W plus 6 and we do need to double it because there are 2 lots of W's and there are 2 lots of 6. So that is correct. And then the next one says 6 plus W plus 6 plus W. This is also correct because we have got a 6 and a W and a 6 and a W. So that is also correct. So we have 3 methods here that can all be used to find the perimeter of the rectangle. And what we've done is we've just done a bit of eliminating as we're going through, just testing each one to see if we agree that it would find the perimeter. Paper 3, question 21. There are 25 classes in a school. Each class has 34 pupils. 62% of all the pupils play a sport after school. What number of pupils do not play a sport? Okay, so there are a few different bits of information here that we might need to underline, and also we need to pay special attention to the actual question, which is what number of pupils do not play a sport. It's quite important that we pay attention to that. Underline it, circle it, star it, whatever, but make sure that you answered that part of the question. So we've got 25 classes in school. Each class has 34 pupils. And then 62% of all the pupils play a sport after school. So the first bit we want to know is what is all the pupils? Let's do that in a different colour. What is all the pupils? So we would find out what all the pupils are by multiplying the 25 classes by the 34 pupils. So the first thing we need to do is 25 by 34. I'm going to pop it over here because it's easier for me on my screen. Obviously you would write it just on your squares. So 25 times 34 is just a long multiplication. So 5 times 4 is 20, 2 times 4 is 8, plus the 2 is 10. Placeholder. 5 times 3 is 15, 2 times 3 is 6, plus 1 is 7, and then we add them up. If you are not too sure on long multiplication, then this is in my numbers calculation ebook. Okay, so 62% of all the pupils is 850. So 62% of 850 play a sport? What number of pupils do not play a sport? And we need to pay attention to this. It's what number of pupils do not play a sport, not what percentage of pupils do not play a sport. So there are a couple of different ways to do this, and I will tell you the way I would do it, which I think is the most efficient. Now you could find 62% of 850 and then subtract that to find the children who don't play a sport, or we could just find the percentage of the pupils that do not play a sport. So if 62% do play a sport, that means that 38% don't play a sport. So we could just find 38% of 850. So it's going to zoom in so that I can write a bit clearer. So 38% of 850. So calculating percentages is found in my ratio and proportion ebook if you are not sure how to do it. In this instance, I'm actually going to do 850 times by 38, and then I'm going to divide the answer by 100. So if I do the answer in a different colour, 0 times 8 is 0, 5 times 8 is 40, 8 times 8 is 64, plus the 4 is 68. I'm just going to make this a bit thinner and go to another colour just to keep it nice and clear. So we're now going to do placeholder. 0 times 3 is 0, 5 times 3 is 15, 8 times 3 is 24, plus 1 is 25. Okay, so we're just doing some simple long multiplication here, and then we are adding it all up. 0 plus 0 is 0, 0 plus 0 is 0, 8 plus 5 is 13, 6 plus 5 plus 1 is 12, and 2 plus 1 is 3. So 32,300 is 850 times 38, but 38% is the same as 0.38. Okay, and 0.38 is 38 divided by 100. So I need to divide, so that divided by 100 makes 0.38. So this answer divided by 100 will give me my actual answer. So to divide that by 100, each digit moves to the right 2 spaces. So it would be 323. 323. Now, another way you might look at it is, I know that 50% of 850 is 425. So I know the answer is going to be a fair bit lower than half. 38% is a fair bit lower than 50%. So I know it's definitely going to be less than 425. So I know I'm in the right ballpark there. And you could also do 40%, subtract 2%. You could do 30% plus 5% plus 3%. All of these different ways will get you to your answer, but it is all about finding out that you need to find 38% of 850. Like I said, you could have also found 62% of 850 and subtracted that. In fact, I could probably do that very quickly now. 62% I'm going to do as 50%, 10%, and 2%. So 50% is 425, 10% is 85, and then 2%, well, 1% would be 8.5, so 2% would be 17. I could add all those up, 5, 10, 17, 2, 10, 11, 12, 4 and 1 is 5, so 527 children played sport. And then if I did 850 subtract 527, I can't do 0 take away 7, so that becomes a 4. 10 take away 7 is 3, 4 take away 2 is 2, 8 take away 5 is 3. Look, I have the same answer. Paper 3, question 22. Megan uses these number machines to calculate how many diagonals different shapes have. And we have some various shapes down the side: triangle, quadrilateral, pentagon. It's labelled how many vertices they have. So vertices are the corners. If you're not sure what vertices are or what diagonals mean, then there are plenty of lessons on shapes and their properties in my geometry ebook. We divide that by 2, and that tells us how many diagonals there are in a shape. So we're using a formula, an algebraic formula, to calculate how many diagonals a shape has based on the number of vertices. Complete the number machine for the octagon. So for this, we need to know how many sides an octagon has. So an octagon has 8 sides. So if you don't know how many sides different shapes have, or how many vertices, they have, then you really need to check out the geometry ebook, and because you do need to know these common polygons, how many sides, vertices, parallel lines, all these kind of things, the angles, all that kind of stuff you need to know. Okay, so the next bit may not be as straightforward, but there is a pattern. You can see that from triangle it's 0, and then it's going up by 1. So quadrilateral is 1, pentagon is 2. Now you could either write out a 6 and 7 sided shape, and then you could put in, okay, well that's going to be times 3, that's going to be times 4, so that means that's times 5. Or you might spot the link between this and this. It's always 3 less. Always 3 less, so 5 is 3 less. Okay, so either way, there's a pattern there. If you spot the pattern, you just need to continue it. The third bit is always divided by 2. So that means that's going to be divided by 2. And now we just need to calculate. So we're going to do 8 times 5 is 40, and 40 divided by 2 is 20. And that's your final answer. If you look at the other ones, just to check, 3 times 0 is nothing, divided by 2 is nothing. 4 times 1 is 4, divided by 2 is 2. 5 times 2 is 10, divided by 2 is 5. So we're just following along, and the last box, the number of diagonals, is the answer to the formula. If you're looking for some effective revision to help you with your maths SATs next May, then check out my SATs ebooks. Each ebook covers an area from the Year 6 National Curriculum, so you can be sure that when you sit your SATs, there will be nothing that you haven't learned. I also have lots of short revision courses. I have practice arithmetic tests, and in the ebooks, there are loads and loads and loads of examples of past SATs questions. So check out the Pocket Private Tutor Shop to help you with your SATs revision.